Welcome back, guys. I hope you've had time to make yourself a cup of tea or use the bathroom. That was a great opening session hosted by James with Carl and Rob from SAIC. Now we're moving on to our next panel session with Autodesk. We've got Phil Botley from Autodesk and Steve from Geodyme. Hi, guys. Great to have you back. Phil, you were involved in the US version of this in December, and we've done a whole series of Autodesk webinars on CDN. Can you tell us the sort of style you want to go through today on how you want the program to work?
Yes, of course, Abel. Yeah, good to see everyone again. Good morning.
Morning.
So Steve and I and one of my colleagues, Barry, who's in Detroit and asleep now, did a kind of a series of talking heads last year, which went down really well with a lot of customers. So much so that a Korean customer specifically pulled Steve into Korea for 3 months based on some of the conversations and discussions we'd had. So we wanted to kind of really kickstart a series of discussions like this, like a rolling talking heads program. And this is going to be a sort of the next stage in that, where Steve and I will just really talk about some of the trends in automotive that we've seen, 50 years when you combine our kind of time together, but also look forward, because what's happened in the past can really inform us from a design perspective, from a digital tool perspective. And so we're just going to talk around a few ideas around surfacing, experience design, future trends, some of the patterns that we see. I get Steve's insights and my insights, and just really chat about these things, right? Explore, some of the trends which are happening, and that kind of contradiction that is digital design and automotive, really slow, but also seismic changes at key times.
Yeah. So can I add to that and say that part of my job then in this session is to kind of collect the questions from the audience. So, I can see, we've spoken, Phil, about how Steve's a bit of a rock star. Well, he looks like a rock star with his backdrop and the health and safety option behind you over your screen. So it's kind of like, I'm gonna actually reduce myself. When you've naturally finished, guys, bring me in and I'll bring in the questions from the audience. So over to Phil and Steve.
Great, thanks, Abel. Appreciate that. Well, good morning, everyone. A great introduction from Abel, and this is really sort of, I'm not saying it's an Alan Bennett talking heads, but we're going to begin to explore some ideas, and hopefully we'll have a bit of a cadence for this, and this will be a regular event where we all get together and talk around some of the ideas. So I guess first of all, introductions. My name is Phil Botley, Alias Product Manager. Been doing this for a long time, managing products in surfacing, and I've known Steve for a long time also. Steve, over to you for an introduction.
Well, my name is Steve Covert. I run a company called Geodyme. I've been involved in surfacing sort of A-class and CAS over the years, since about 1988, so about 30 years. And so I've been involved in actually doing the job of surfacing, but also training users up, probably hundreds of users, to be honest, over that time period. And so I've seen a lot of changes, but a lot of things have also stayed the same. And the fundamental process of designing has not really changed in its core. Even surfacing from the point of view of years ago when I started, using a system called computer vision, it's basically exactly the same technology that's used in Alias and ISOMSurf today. Just it worked, everything works a lot faster now. Of course, you can do more changes.
But I mean, that's an interesting point you make, Steve. So I got this kind of introduction set aside. It really nailed that point precisely. That if we look back, if we look at Alias, Surf, CAD, whatever, those tools are still used right today. They're in the same way, in the same process, and we have these kind of technology enablers such as real-time rendering or game engines that come and bolt onto the side. But, as a whole, the tools are still being used in the same way as they have been for 25 years.
Yeah, absolutely. I mean, in the days of computer vision, we were doing the same thing of pulling CVs around. But it used to take, I remember we used to sort of quote 16 to 19 weeks to do a bumper. And now a bumper you can do in a week or two at the most. And you probably put some iterations in there as well.
I mean, do you think that's down to the fact that the tools are they are by definition tools, right? It's like a pencil, Photoshop, or your clay modeling tools, that they just work so well, and have been evolved and mature that they're still pertinent. Yeah, we have fast form finding up front with sub-D, poly modeling, and those sort of components and computational design around it. But fundamentally, those surface sculpting tools just get the job done.
Yeah, absolutely. And I think it's the skill of the user. I mean, it's the same thing applies to clay modeling, of course, that, clay modeling we thought years ago that clay modeling would die off because of digital tools, but it hasn't. It's still there. It's fundamental. It's a core part of the process that people need to see something in a real space, real size, and there's nothing that can, get away from that. And but if we do move it into a world where VR is the tool for the future, maybe, then the clay modeling skills are still going to be required. Much like the surfacing skills are still required in exactly the same way that they were 30 years ago.
I mean, it's an interesting point you make. We've been having many chats amongst ourselves, but with a number of customers about concept of you go into the studio. Remember in Binley, we'd go in, the clay models would be there anywhere, and you'd look around and you just check what had been milled overnight or whatever. But what we're seeing now is a lot of design managers wanting that concept in virtual reality. So that immediately, or on screen even, they can walk up, come into the morning and see the latest car on the screen with all the geometry in there. So there's a kind of parallel between the way the virtual world is going from that perspective. It's not just clay modeling virtually, but actually that same checking the model and seeing what state it's at and refining it.
Yeah, and I think that the beauty of the clay model or that virtual reality model or whatever it is, that product, being able to see it in full size, and every morning you walk past it, it enters your brain, and you're constantly thinking about it as a result of that. Whereas when you're isolated on screens, the designers aren't necessarily aware of what's going on every single screen. It's just not possible. But the clay model or the virtual reality model brings everybody together to discuss exactly the same issues around the same model. I think I can see the advantage of virtual reality in the future is that whereas the clay, you can only get maybe 10 people wandering around it at any one time. Virtual reality is unlimited. How many people can interrogate that model at any time?
I mean that's a good point. So as background for viewers on this course, we mentioned before, Steve and I and Barry, one of my colleagues, did a session a few months ago, maybe 12 months ago actually, and a particular customer in Korea wanted to get Steve's process knowledge and to help them really change their process. So he was out there for 3 months in the middle of COVID. That's a different story. Probably a good webinar in that, Steve. I think. But this particular customer is very focused on what Steve just said, really fusing and blurring the boundaries between the virtual and the clay. So in their studio in Korea, they have one design studio room which has got 3 clay plates in, I think, and you can walk around. And next door they have exactly the same scale, but it's designed for virtual reality. So you can have 40 or 50 people in there looking around the model. And they're doing these design reviews globally, Germany, Korea, America, etc. But what they're beginning to do now is use this concept of extended reality, augmented reality. So really project the kind of the model next to the clay or onto the clay. So Steve says, you can put 6 or 7 different variants or lights on there on the clay. You can overlay it, you can interact it. So there's a real kind of, there had been divergent, but there's a real now convergence of physical, of virtual and real to create a fused reality, which I think is really quite exciting in the studios. Yeah, I think in the design process, one of the other things that is a major cost saving is when you make sure that all the major changes happen at the beginning of the process, not at the end. Because the number of times I've been involved in projects where we suddenly find a last minute change, like
somebody's discovered that the golf bag won't fit in the boot. Right at the last minute, everything's been surfaced, everything's been engineered, and it's so expensive and time consuming to make that change at that stage.
Yeah.
The more upfront you can load all of those changes, the better, in terms of the cost and the difficulty of doing it. And I think the idea of virtual reality or augmented reality can enable you to make those changes much earlier on and highlight those difficulties.
Well, you can see, can't you? You can sit inside the car. You could walk around the car. You can put your golf bags in there, so you get an idea of space and reach and envelopes and what you can and can't do. And critically, you can't cheat, right? You can't have a 5th percentile Chinese mannequin is your driver and kind of squash all the proportions and everything. It's
absolutely.
It's a real truth of sitting inside the car.
I think sitting inside this car is a very good point, actually, because I've had the experience of companies making a mock-up of the car off all of the A-class surfaces, and then discovering that actually it feels a bit claustrophobic. That maybe the center console is encroaching on the foot space. It's not something that you see in a CAD model, but you feel it in reality. And I think virtual reality is the closest you can possibly get to that experience, way before you get to that point where you've spent so much time and resource developing A-class surfaces, and then having to rip up the design. Likewise with ingress and egress into the vehicle, and the envelope for your hand, or arm movements to adjust seats and that sort of thing. Those sort of ergonomic considerations that you can't see on a screen. It doesn't matter how much analysis you do. You can't assess claustrophobia on a screen. You can assess it in a virtual reality or a real physical space, but obviously virtual reality is a far more economic way to achieve that sort of thing, I think.
Again, I suppose if you have the virtual reality books and you have that experience, then that's a kind of a nice gateway to redefine customer clinics, right? So if you have that data set and it's of a high fidelity and quality, you can then reach out to an audience. You don't have to. I know companies don't do this anymore, but you don't have to fly your Bentley to Mauritius or something to take photographs or to do that. You can now run your customer clinics in that way and get a broad spread of acceptance and identify those problems really early in the process.
Yeah, I think that's a very good point. And of course, you can do it simultaneously as well, can't you? Which you obviously can't do with a physical property.
Yes, and I think that's also the really interesting point you make there, Steve, because it becomes kind of concurrent process, right? It's not silo, stop, start. You're continuously evolving with the customer in the loop and the feedback, whether that be the designer or engineering. It's a really important component.
Yeah, that's very true. Yeah, I think the more parallel the process, that's got to makes things so much more efficient, doesn't it?
Yeah. And I think that's to the point you made before, which I wanted to kind of just explore a bit more in terms of, obviously when we're designing software, which is what we do, right? Design change is cheap up front, right? If you can socialize your design. We're doing it at the moment with some of our UI projects, and we're super fast at changing these things. And I think the same is important here. But you have that problem, don't you? You don't really want to introduce and constrain design intent by hammering down on manufacturing feasibility. So how do you get that balance? How do you get that balance of creativity, but also manufacturing feasibility? So 2 years down the line, it will pop out of the mold.
Yeah, I mean, obviously with a clay model, they put in hard points and they respect the feasibility as much as it's possible to do. But with the benefit of a CAD system, of course, is that you can put those high points in, and you know at all times that you're not encroaching on those high points. Virtual reality gives you the best of both worlds, in a sense, doesn't it? That you can measure things accurately that may be hidden, and at the same time create an accurate surface model which reflects design intent.
Yeah, but I mean, But there's also things, I mean, and this is some of the things we're trying to solve. So we're kind of still serial in our approach, right? Where we might make the model, then we might analyze it, then we might change it, then we might analyze it again, and blah, blah, blah. And so what we're trying to do with some of the tools we have is to have this stream of analysis running all the time inside of Alias and other tools. So Alias begins to help the modeler based on, and we'll come to this in a moment, design language and surface templates based on manufacturing criteria, so it can guide the user down a particular way, saying, just be mindful on this, maybe want to put a bit of crown on here, and then these are some areas that you have to investigate. So getting away from that kind of manual process, stage process, but running the analysis in parallel, but not constraining design intent. I think that's going to be quite important moving forward. Definitely.
I mean, that is one of the things that, back in the day, 30 years ago, when I transitioned from computer vision to ISIMSurf and Alias, that was one of the key benefits, was the fact that you could simultaneously measure things and look at the quality of a surface at the same time. And it was happening in real time. Whereas in the computer vision days, it was you would modify a surface to give you the shape that you wanted, then you'd measure it, and then you'd think, well, now what do I do? And the two it was a linear process. You did one and then did the other afterwards. And ISIMSurf and Alias came along and completely changed that mindset. It was virtually overnight.
Yeah.
And as you say, if you can do the same thing in the whole process, then there's huge savings to be made, I think.
I mean, certainly what we're seeing, and probably you're seeing as well, Steve, is we're seeing that kind of blur between disciplines, right? So we know this is happening, whether the definition of styling, class A, it's getting blurred. Rightly so, we have to collapse the time. But what we're seeing now is that blurring of surface release into engineering and body in white and manufacturing and feasibility. So we have one interesting project where we're beginning to bake, and this is madness, right? We're beginning to bake what would be traditional CATIA manufacturing capability into our software, right? With Dynamo, a computational tool. So when we get data from the suppliers, or when this customer gets data from the suppliers, they can check it and make sure that it has all the bits sorted. But critically, when a surfacing it or the CAS team are maturing it, it is going into this database and checking what the type of metal is, the spring back, the plastic, and actually giving that feedback to the stylist, saying, actually, you probably need to do this, or that's not going to work. Maybe do that, and that sort of blurring also between surfacing and engineering is another pattern that I'm beginning to see and pick up on now in our customers.
Definitely, there's blurring of all these boundaries, isn't there? There's, I think one of the things that certain designers I've met over the years actually do A-class surfacing. They'll take their concept all the way through to A-class surfacing, which is very rare. But a lot of designers, can hop onto Alias and do some surfacing in there to show a 3D concept. You've got concept modelers who are quite capable of doing A-class. You've got A-class modelers who are quite capable of doing concept. In fact, in the A-class departments, you often these days you will get a sketch from a designer to do a change. It might not be the major surfaces, but there'll be some area like a vent or something where you're given a sketch and you have to work from that. So the job roles and the divisions between departments are gradually breaking down. I mean, in terms of clay modeling and VR, I see those as very relatable activities. This the ability to be able to model things in a virtual reality environment. I mean, years ago I trained some clay modelers up on ISIMSurf at the time, and they were some of the best people that I've ever trained, because it's the same skill set whether you're working on clay or in a digital environment. They understood shapes immediately. They didn't understand the computer. That was what they had to learn. But once they did understand that, then they could see that it was exactly the same discipline as doing clay modeling.
Yeah,
And
which goes back to this concept of it's sculpting, isn't it? Right? That's what we do.
Yeah.
Clay modelers do, whether it be with the clay tools or with the virtual reality or in Surf or Alias. If you understand shape and know how you can fit the shape and resolve the shape and takes the tail of the dragon, so to speak, then it doesn't matter which tool you use, you're going to be very good at it.
Yes, absolutely. And there's people with different skill sets. There's some people who've got more of an engineering head on them, and some people who've got more of a design concept head on them, and some people who can sort of flip from one to the other. I think the boundaries need to blur more and more.
And this gets us to this really interesting point that you mentioned before about clay becoming more important or relevant. And when you have that there, and with the fast milling and the fast scanning, and you have the understanding of the virtual world and clay modelers and cast modelers, you get to this really interesting concept of of patch planning, right? Which is a dark art for a lot of people. It's magic. We don't really know. We're not going to tell you how to do that. But we're now in a situation where we can begin to learn about patch planning, right? We kind of know what the manufacturing criteria is to get it into CATIA or NX or into production. We know how the surface layout works for a particular car. And so we can actually begin to look at not automating patch planning, but understanding how patches are made up. So we can capture that knowledge and begin to apply it to models automatically, which I think is an interesting comment. What are your thoughts on that, Steve? What do you think on that?
Well, that is a really interesting avenue. I mean, when I was at Rover, again 30 years ago, I'm sorry to keep harking back to the old days, but
the past is prologue, Steve.
I actually did a project which I called AutoSurf, which was looking at exactly that, was creating surfaces, knowing what the patch plan would likely to be. So in those days, Rover cars it was fairly predictable what a bonnet might have on it. It was either going to be a single surface or it might have a couple of features on it. So from knowing what the topology of that area was, I developed this program which would actually surface that in computer vision, because computer vision had this wonderful programming tool which I used to spend a lot of time dabbling with, and that worked pretty well. But you had to know what the topology was. But I think these days with machine learning and artificial intelligence and that sort of thing, I can see the potential for taking something like that and developing automation within a patch planning, because there's certain patch planning rules that we follow that we may not be quite conscious of, but they're definitely rules that we have in place when we're surfacing, when we're thinking about surfacing, and like you say, particular areas of the car are always patched up in the same way.
Exactly.
Unless there's something unusual happens, but a roof is a roof, it's a roof, and it may have some features on it, but it doesn't really change that much from one saloon car to another. And
so some sort of knowledge-based system based on the patch planning and design language per user, per project line, per customer is certainly something that we're looking at. I mean, you make a good point about the work you did. I mean, I hope, thank God, some of our developers are still in bed. They're in Toronto, right? So they heard you saying that. They might be worried about their jobs if you did it 30. I'm joking, by the way, guys. So,
yes.
And if the Hanover crew are watching, and I know you're up, don't worry. But that really gets to this kind of, this nub of collapsing stuff, right? And making those design changes, decisions as early as possible. And if you can, if you can collapse that, or make it parallel that manufacturing feasibility of your surface geometry, all of a sudden you've bought yourself months, right, in your design time.
Yeah, absolutely. I mean, I think if you retain the clay model in the process as well, the idea of being able to automatically surface from that, even if it's not A class, something that's approaching that sort of quality, something that people can then work with. If you could press a button and produce that surface, so you've simultaneously got the surface model and the clay model, then that's another way of introducing a level of parallelism in the process, I think.
And that's we did some work last year with Cole, where the sort of milling guys, where they'll take the alias data and they'll have a sort of chucking the clay on. They've got a squirter on the arm, so they'll squirt the clay on, then we'll mill it. Yeah. And then we have a concept which our consulting team implement with customers called this live scan, where we're always scanning the model and we're always feeding it into alias and it's rebuilding imagery. But there's a good point you make about the clay, and I wonder if this is perhaps a resurgence of the clay, because we know clay models are very expensive. Of course we do. We know people do sign off virtually, and some people do that. Some people don't like the clay. But the actual machining and the milling and the scanning and the surfacing, we can automate that, and maybe there's a new lease of life for that.
I think the fact that the clay has not died off yet, that companies are still using clay, shows that it's an essential part of the process. It's not to say it won't be replaced at some point in the future, but I think you've got to, it takes a long time, I think, from a process point of view, from a cultural point of view, to make these big changes. But it doesn't mean that won't happen. It's like, overnight computer vision was dead and ISM Surf and Alias were suddenly taken on. It was an overnight change. But these things do take time, and there is a cultural change as well. I mean, obviously, I read on LinkedIn and various other places from clay modelers saying suggesting that they feel a bit threatened by technology, in a sense that it might take away their job roles, but I don't actually think it will. Like I say, with virtual reality, modeling is the same skill set as clay modeling.
And I think that's a very good point. Also, it's a kind of a new lease of life for these. They're not anachronistic clays; they become more important because the technology just gives them superpowers, really, and turbocharges them. I mean, I'm in my job, I'm super lucky, right? I get to travel the world and go and see all automotive customers. And one of the best places I go to and is Japan, right? And see those guys. And as you travel further south from Tokyo all the way to Nagoya and then into Hiroshima, there's a real change. I mean, the process is different anyway to European or Western. But as you move further south on the main island of Japan, very back to basics. It's very back to craftsmanship. And the clay is king in these companies as you move further south. And there's a real a kind of resurgence and belief in clays at the center, because they can refine the shape very quickly and get some of those lovely flowing lines that those companies have. And I think there's something. It's a trend I noticed a couple of years ago, and it's something that I'm beginning to notice now feed back into companies in Western Europe and America, because we've got these automated processes around the clay, faster to mill, faster to scan, faster to surface, which gives it a new lease of life. Yeah,
definitely. Yeah, I think the idea of milling from digital data, which is what we did what was happening on the Ford GT, for example. They milled from the CAD data from our A-class surfaces straight back onto the clay. So they always had a clay, but that process is fantastic to see those surfaces appearing within a day. So that I think it's just all about communication between all the parties. So it's no good just having the model on the screen, on a flat screen in front of one user in a department hidden in the corner. You've got to have it. You've got to physically put it out there as quickly as you can, so that other people can collaborate with it, and then you get the best products in the shortest space of time.
Yeah. I mean, and that leads us into kind of the whole collaboration experience topic, right? Which we talked about surfacing, clays, digital modeling, patch planning, automation. Bolted onto that is, well, if you have these parts and they're siloed, then it's no good to man nor beast. So how do you collaborate? How do you communicate? How do you replicate the boards around the clay with the sticky notes on, or the 300 tape lines on the fees of function cube model in the virtual world? And these are some of the supporting tools which we're beginning to see really mature now, I think, and bolt onto these packages. And I think from a collaboration in virtual reality with post-it notes or with audio or with tapes are also really important. And as you say, that central pipeline, right, of everyone sharing data, visibility at the same time is really important, I think, for communication.
Yeah, definitely. It's something that people feel uncomfortable with when they, I remember in the early days of surfacing, I certainly experienced it. When you're first learning to surface, you're a bit precious about what you've got on the screen. You don't want to show anybody because you think they might pick holes in it. But actually, that's what needs to happen at every stage of the process, and it is a cultural thing that you eventually get over. That you want people to come, you want the designer to come up and see your model as soon as possible, so that you know that you're on the right track. And get the engineer. I mean, I've been in situations where I've had an engineer on one side, the designer on the other side, and within a few hours between the three of us, we've got a product developed that would have taken weeks otherwise. If one person had done it in isolation, then sent it off to the engineers, then they'd come back, and then the designer had looked at it and said, no, that's not acceptable. It would have taken weeks. But you can do these things in a few hours if you all get together and all have that input at the same time. And if you can overcome the cultural barriers, I think the cultural barriers are a lot fewer than they used to be. There used to be sort of virtual hard walls between departments, and those have broken down a lot over the years. But if you can get rid of all those last vestiges of barriers between silos, then great.
Yeah, no, I think you're spot on. I mean, the project we did back end of last year wasn't really solving a technological problem. It was really solving a cultural problem in terms of removing those barriers between departments. And once you have that common language, common understanding, it really becomes a lot easier to to communicate and collaborate.
Definitely, yeah.
I think it's really quite exciting, and it makes an interesting point that we are, spotting these digital trends, these changes in tools, automation, digitalization. But that is actually the solution to the problem a lot simpler. Putting people together, training engineers in Alias or Surf and vice versa, and beginning to create teams. I mean, I know we have the concept of studio engineers and teams, but in our development process, we have this kind of Scrum-based approach, 3-week sprint. So we'll stick development, development, design, and cross teams, and really get people working together. And I'm seeing that trend also appear in a lot of automotive companies, where now when they talk about agile, it's a kind of a process methodology, development ops, right? You can move very quickly, reprioritize. And I wonder if that could also unlock that, Steve, where you have small groups of people coalescing and working together.
I think that is a good point, actually. I think that, from what I know of the software development process, that seems to be a very efficient process. I mean, in software development, in startup companies, you have this concept of minimal viable product and things like that, where you're prototyping stuff very quickly to your customers and seeing whether you like it. And you could do the same thing in the car industry, as you described earlier on, but also the idea of agile teams. An example of where it wasn't an agile methodology or Scrum system as such, but I worked for this company called Modec, which is quite a small company, but we produced not only a prototype electric van in a year, but also the production van within a year. And there was only about 40 people in the team. And we used to have morning session where 20 of us would stand in a circle and discuss what our particular needs and problems were and what data we were lacking. And we literally spent 15 minutes doing that meeting. And the manager would just say, well, you need to go and speak to him after the meeting. And we got things sorted out very quickly. In fact, nothing seemed to be a problem because it was identified so quickly that it never became a problem. It never became
quite ahead of its time, really, Steve.
It was absolutely I mean, it's a fantastic environment to work in,
Mm.
because you're literally all in the same office and you're all collaborating with each other, and you're all understanding each other's needs and problems. So nothing became a big issue at the end of the program where we suddenly discover the door won't open or anything like that, which then requires a crazy amount of work and a crazy amount of resource. You just iron out all of the problems along the way.
Yeah.
And
I mean, it's an interesting point. I was talking with an aerospace, someone who's involved in the aerospace industry, has been donkey years the other week, about that very point, agility and decision making and digital tools. And he was saying one particular aerospace company, one of the big two, are now using that and seeing significant savings in their design process. Getting the interiors or the business jets or whatever, getting them out a lot quicker because they're solving those problems in 15 minutes as opposed to 15 months. I think it's really quite.
I think the trouble is, if you have obviously you need record keeping and you need some formal record of what's going on, but I think that much more agile, much more direct communication is so much better than having a formal releasing program at every stage where you have to fill in endless paperwork, and then something goes off to another department and you don't get back any information for 2 weeks, and you find that other people aren't working on the same data that you're working on, and all of those things just lead to such inefficiencies versus just talking to each other on the spot and getting it sorted.
But and again, I think that in the essence, that communication, not just internally into department, but externally, is something that I don't know if you're seeing it, but I'm seeing it. As Autodesk, we have a suite of tools called Maya. And Shotgun, of course, right, from media and entertainment. Any film, well, maybe not recently, but any film you've seen on Netflix or Amazon recently that has CGI. I was watching Wonder Woman last night. Really cool, all done on our software. But it's really it's really interesting in terms of what these guys are looking at. And I always have these debates with my fellow product managers in Maya, saying automotive is slow, and I'm saying no, and media and entertainment slow, and blah blah blah. It's a trend I'm seeing there now, where they're looking to connect directly with the customer. Right? So they have this concept maybe of making something in Maya and then getting straight into a game like Fortnite. So potentially our kids or our kids could be making models. And one of my guys, Barry, who we were talking with, a few months ago, his son's doing this, right? Building the geometry in Alias and Blender, sticking it on the Fortnite shop, making dollars from it, right? This is like 11-year-old boy, maybe 8, maybe 11, modeling this, and it struck me that we now have this ability to connect directly from the end user right into potentially the design process, vice versa. So I wonder if that connectivity will break out of the automotive customers, allow designers to reach directly into their customers, influence their design, build your parts, prototype your parts, build your own HMIs. I don't know if that's a logical extension of this of this blurring of the boundaries of communication.
It does make sense. I mean, the more direct communication, as you say, with outside the company, straight to your customers, is going to be hugely beneficial to the quality of the products. And it's what software companies do with the minimal viable product, where they just push something out that's actually not very good, but it's got the key features, and see what the customers make of it. I was reading about some company that did they wanted to do some sort of virtual reality game, and they couldn't afford to actually do the animation of transporting somebody from this character from one location to another, so they didn't bother. They just switched from one location to the other and called it teleporting, and the customers thought this was a really cool feature, but it actually cost them less money than if they'd done it properly. And of course they got the feedback immediately on that, and immediate feedback, I think, from customers has got to be a good thing.
And I think that it can really influence your design, and I think that, coupled with the collapse of the design process, So you can get your products out super quickly, react to market trends, whatever they are, whether it be your iPhone or whatever. I think that's really going to be quite important. I say the next few years, it's automotive, right? So probably the next 25 years it'll take to filter in there. But I just sense there's a change coming, and the customer becoming important earlier in the process. And the tools changing to support that. I think that's a really interesting pattern we're seeing.
I think that, and there's so many changes going on at the moment, on the technology-wise. You've the maturity of 3D printing now, that you can 3D print in metal, and that you can actually make production parts that are 3D printed, which may be low volume at a fairly cost-effective price, and you've got things like generative design, which sort of go hand in hand, don't they? That you can generate a model that's actually meets all the loading criteria that you in the past you wouldn't have been able to make, but now you can with 3D printing you can actually make physical parts which actually can sit on the car rather than just being a prototype.
Well, exactly right, exactly, and conceptually you could have this situation where if you have your manual. And a part breaks. The parts don't break on cars these days, but the part did break. You could go to the equivalent of the OEM Turbo Squid, download the part as an STL, and just print it in your back garden. Not your back garden, but your shed, maybe.
Yeah, sure. Yeah.
Just make sure you get the scale right.
Yeah. Well, the other thing is, if you have a part that does break in the field, if it's a 3D printed part, it's fairly easy thing for them to redesign it or to strengthen it in some way, and then change the manufacturing almost at the press of a button. So that you start producing a part that does meet the requirements. Yeah,
and I think there's a lot of change. We did a nice project recently for one of our colleagues it's just an example of 3D printing, and it was it's a good story. It's a really lovely story, right? This is a sledgehammer to crack a walnut. She was moving house with her wife, and she wanted to really build a model for her mother who's deaf and blind. I used Alias to model this house, right? His sledgehammer to crack a walnut, and we 3D printed it. University of Warwick or our centre at Birmingham just did it in like 24 hours. Shipped it to her. Her mum was happy; she could walk around it and got that sorted. And I think that's really kind of shows how it's democratized, right? You can buy a printer, you can have a printer in your garage, you can print anything. As you said, if you're going on an expedition, even to the moon, perhaps. I mean, I've seen stories about this. You don't have to take all your parts with you. You just take a 3D printer.
Oh yeah,
data, and you can just print it. I mean, I just had a message from Abel saying we've probably got a couple of minutes left, Steve, before we have to go to answering. So I just wanted to really kind of, sort of wrap all this and sort of wrap it all up into, just a series of conclusions and observations in terms of, trends. As you look backwards, seeing where you started with CADs or surf, and where we are now and where we are forward, what are your highlights? What do you think is really going to move the needle and the dial for our customers and for our process and design teams?
I think the virtual reality is definitely it's sort of still in its infancy to some extent, but and I mean I can see maybe that augmented reality more than virtual reality, maybe the way that will go, because the idea of wandering around in a virtual environment with virtual avatars of your colleagues, for example, is not quite as appealing as being able to see the model in the studio as though it's really there, and you can discuss it with your colleagues in real life. Because that's obviously something that we've all realized, over the last year is missing human contact. There's, we're still humans, and we still need to communicate with other humans. It's doing everything digitally is great, but that human contact is something that we all miss, and I think it's a vital part of the the design process for sure. And understanding, when you're working with a designer, for example, understanding what they're seeing in their vision is so important from a surfacing perspective. You get that intuition only from another human. But I think augmented reality, maybe the longer distant future.
Okay. All right, so that kind of fusing of the real and the virtual. So it's humans in the studio, clays, virtual geometry overlaid it, and people collaborating. That's
and what will not go away is the human involvement, the skill sets of people. They may change, they may merge, and people may become faceted in that sense. But that will still be a vital part. So I think it's interesting. Sorry. I think it's interesting that so much has changed and then nothing has changed all at the same time. We're still doing surfacing in the same way, and we've still got the clay model there. We still need that physical property.
But I think what's going to happen though, I think these parts will just these tools are still there, but on top of them they will become more efficient and super quick because we'll be able to extract information and knowledge to reuse it, right? Whether it be design language, patch planning language, surfacing language, computation, automation. So we'll still have those tools that still work in the same way, but the kind of an abstract layer of knowledge and information informing the design process around there, which combined with communication, as you say, collaboration, virtual reality, and those kind of cultural issues. Are really some of the exciting challenges that we have. That we'll see, I hope, next 20 odd years.
I think it boils down to working concurrently. That's what's going to really drive the technology. I think is the ability to be able to work concurrently, and that dramatically shortens the process and improves the quality of your vehicles.
It's just good, Steve. But I'm conscious that Abel is texting me, slacking me. Sorry, I'm not slacking, messaging me. So many platforms these days.
Right.
That we have some questions. So I think Abel, we're probably going to call that time on our little fireside chat, the first of many.
Wow.
And over to your good self.
Well, I want to say that you guys are counselors for the design community, bringing engineering designers together. Are you crazy?
Oh, no, mate. We're not going to be allowed in the studio ever again.
I love you guys if you can cure this problem. I'm going to get some questions here, so I apologize if I look. I've got a second here. It's from Aaron, who's in Coventry at the moment. Hello, Phil and Steve. I recently read the 2008 Technical Surfacing PDF, one with Daniel Simon's bike on the front cover. Do you have any more great surfacing handbooks like this? I really want to go far into this as a student, aid my design capabilities. Thank you.
Steve, do you?
I'm aware. Obviously, there's Barry Kimball's fantastic Alias tutorials, A-class tutorials online. Kerry Kingston's as well. They're really, really good, and they're easy to get to because you just fire up Alias, and it'll introduce you to those tutorials at the start of the software. So I'm not aware of the one that you just mentioned, in fact, but
no. But we do have a lot of tutorials, movies. Funnily enough, I've been working with one of my colleagues in China, Ning Ding, and he's just created an absolutely lovely book, right, on how to do this. It's in Chinese. It's a lovely book, Abel. I'll send you the PDF. It's brilliant. But I'm going to get some copies of that. Pictures, you can understand what's going on. But if we obviously we'll get the email addresses afterwards, Abel. But certainly we can forward some links. I can get one of these books to Aaron, and anything else that we might have, so we can provide him with lots of tutorials, online, physical, so he can carry on modelling.
Brilliant. Thanks, Phil. I've worked with Ning Ding, that, in China, and he's brilliant. Yeah. So with Barry and Ning Ding, you've got some great superstars there. I've got another question from Andrea. Hello, Phil. Does Autodesk have a plans to improve collaboration tools in Alias to enable better multi-user surfacing. Sorry, my camera's switching off. Making it conceptually closer to clay modeling, where each modeler is really working on the same model, seeing and interacting with what other modelers are doing.
Yeah, I mean, that's a great question, right? So we have a number of projects in different levels of maturity. So if you look at Alias on the screen, and let's park virtual reality for a second, we have a concept called Alias Assemblies in Reference Manager. So we can actually have the situation where I can have a 12-man team surfacing simultaneously, and the geometry would update live inside of Alias. When I say live, you have to reload it, but it can be live. So you could potentially have the team working together. So I could see what Steve's doing, Steve could see what I'm doing. So we're always working together from a kind of a desktop perspective. From a virtual reality perspective, we have our tool called Create VR, which is our immersive modeling tool. We're in the process of extending that capability with a view to having true collaborative modeling inside a virtual environment. So not just the design review tools that we have with Red at the moment, which are really cool, but also building around that so we can model together, we can tape together. As Steve said, we could annotate together and make the notes and pull and deform geometry. So short answer, yes, we have an approach that works currently in Alias, and as part of our roadmap, we're looking to make that more intuitive for modeling collaboratively in a VR environment, pulling the shape, deforming the geometry, and talking and making notes.
Excellent. I've got a question from Gwendell Philpott. I mean, that's such a cool name. Based in the US, actually.
Ooh.
When Intergraphic dropping UNIX and iDesign, Attilio Grimaldi left Intergraphic and went to work for Autodesk. Phil, do you see Alias 360 and Inventor meshing?
No, I don't see that at all, and I don't. I know that some people are slightly worried by that. Alias is a standalone surface package, has a modeling kernel that doesn't really integrate well with others. That's why standalone tools like Surf and Alias are really good at their job. But what I do see happening is over time us maybe helping the Inventor or Fusion team with aspects of surface modeling or industrial design. So not actually putting Alias inside of Fusion or vice versa, but perhaps, an example, taking some of our sketching technology and adding that to Fusion, maybe working to optimize T-splines in Fusion or putting sub-D into Alias. So I don't see them meshing or fusing at all. I see Alias staying as standalone and getting better and enhancing as we're doing, but I see us helping Fusion and the surfacing modeling tool sets in those products moving forward.
Okay, and we've got another question from the UK. Do you find with digital that more changes requests tend to creep in? What is the key to define and agree to a project scope?
I can let Steve answer that from that perspective. I can answer it from a software development perspective. Steve.
There's always changes. I mean, that's the main part of the job, really, is adapting to the changes and anticipating them. You really have to build your surface models. I think the most important thing these days is to build your surface model in such a way that you can change it easily, because it's fundamental. I can't think of a single component in the last few years where I haven't done like 30 to 50 iterations of that component because of design changes or engineering changes or optical quality changes, or a complete rip up and start again. So changes are just part of the job at every level, I think. Because at every stage you can have a review of design and surfacing, and there's like I say, there's so many people collaborate on these projects that it's inevitable that change is going to happen.
Yeah. I think you have to accept that, embrace that, as Steve said, right? You need to build in the capability to change in your model from the start, and that suggests modeling methodology that is flexible and you can change. And we have a similar thing in our development process. We know, we'll have changes. We know if we get code out, it will have to change. It will be fixed over time. We just accept that it's never ever correct first time or 100% right first time. You always have to bake in that margin for change.
Excellent. We've had lots of thank yous for answering the question. We've got a few more questions, but we've just run out of time. We'll send them to you. Some of them are very long, and I don't even know how to say the words correctly. Brands. But thank you for all the questions. Thanks, Steve and Phil. I'm pretty sure if this is the way that we're going to move forward, Phil, we'll have Ning, Ding, and we'll have Steve talking about his experience for the Asian version of the design dialogues, because I'd be fascinated to say how you went over in 3 months in lockdown. That's in itself.
You should see some of the pictures, Abel. You should see some of the pictures.
Next time, Steve, thank you both for your support of the event and giving your time today. I just want to say thank you, Phil, as well, for all your support on Car Design News and supporting the young kids out there who want to be designers and answering their questions. I know it's important to you.
Anytime, Abel. Anytime, mate. Anytime.
Thank you, guys.
You're welcome, Abel.
You're welcome. Good luck with the rest of the event, Abel.
Thank you. Thanks, guys. We're actually now moving to a break. So I think we're going to get Steve and Phil to leave the screen. Otherwise, they can go and have a coffee and wipe the sweat off their brows. Our next session starts at 12:15 with the Teatro Sierra, where we're going to take you to the Warwickshire studio, inside the Warwickshire studio, and the concept with Pratap and Martin, and it's going to be chaired by Christopher Ludwig on the CDN team. So we'll see you in about 9 minutes. See you soon, guys. Thanks for joining.
Prefix is an award-winning organization and recognized leader in the creation of prototypes, full-scale props and mock-ups, and the most technically advanced concept vehicles for the automotive, aviation, and mobility industries. The company is also a source for contract manufacturing, low-volume specialty vehicles, production paint programs, and component assembly. With nearly 300 employees and 4 impressive Midwestern USA facilities, Prefix offers an extremely wide range of capabilities, providing clients with a one-stop shop of crucial services. Actively involved with advanced technologies relating to electric vehicles, autonomous transportation, and urban mobility, Prefix has the departments and skills needed to work with companies throughout the entire development process.
Fake